Okay, now that we've learned a little bit about logs and how they relate to exponential functions, we need to take a look at some of the properties of logarithms that we can use. In later sections, we'll be taking these properties of logarithms and combining them with our knowledge of properties of logarithmic functions and exponential functions, and we'll be kind of putting this all together for our final section. So it's very important that you learn both of these sections prior to moving on to the last one. But in general, we have three log properties that is extremely important to learn and understand. Now, the names are not all that important to me personally, but your application of the property itself. And you've got to keep in mind that you can go either direction with these properties. So I'm going to go to a separate page here and talk about some language that you need to be aware of. So some properties or some directions are going to tell us to expand the log. And when we expand the log, we more or less we want to break it all apart and make it as big a statement as possible. On the flip side of that, you may be asked to condense the log. And condensing the log is to take it an expanded version and simplify it back down to a little bit smaller version until it's completely condensed. So we can go from expanding to condensing, and then we can go from condensing to expanding, and we can go back and forth in either direction. Now let's take a look at the first property that we're going to be dealing with here. And if you see the first property here, we call it the product property. And basically what it tells us is if we have a log that has two parts that are being multiplied together, then we can expand that by making it two additional parts. So we can take addition and break it apart. So I'm going to give you a different form of this. So let's say if I take log, and we'll just use base 5 as a good example, and then we'll say x times y. Now we know that we don't have to write the little dot in there, but it just helps to prove the point. So this is multiplication. So we're going to take the multiplication and we're going to expand it to addition. So our product property tells us, and I'm going to write this out completely, tells us that if we have two parts that are being multiplied together, that we can then break that log up into two separate logs that are being added together. Now, one of the most important parts here is this. First and foremost, each of the log bases are exactly the same. They all have to have the same base log. Secondly, multiplication in this case leads to addition over here. Now, if you had the problem on the left, log base 5 of x plus log base 5 of y, you could condense it going back the other way, and so that would be our condensed model going from addition back to multiplication. So you can take this in either direction. So it's very important that you learn not just one direction but both directions. So let's take a look at the next property that we have. In the second property, we have the quotient property, and so we have a log that has a divided part in it, and so we're going to break this up into subtraction. So let's take the same example. Let's say log base 5, except this time we'll do x divided by y. So division, excuse me, is going to lead us to subtraction. And so that means we're going to have log base 5 of x, and the first one, the numerator, is always the first one, and we're going to subtract the denominator. Again, same log base all the way across, and this time the division part leads to subtraction. So that's a good, hopefully that can help you out a little bit there, that little color coding. Now, if we were being asked to condense this statement, we could then go back the other direction and take this subtraction statement and condense it back to a division statement. So it's very important that you're able to condense and expand these properties. The last property that we're going to look at is going to be the power property, and what this tells us is if we have a power within our log, we can then make that a multiple in front of the log itself. So if we look at another example like this, let's just say log base 5 x squared. So now we have a power, and when we expand that, it then becomes a multiple of the log. And what do we mean by a multiple of the log? That means that we can then say that this is 2 times the log base 5 of x. Now, if we have this, we can use parentheses. Most of the time you're going to see it without parentheses. Sometimes you may see it with a little dot right there. Either way that you see it, you just need to understand it as a multiple of that. So if we are expanding it, we can then condense it back. If we have a multiple, that multiple can then become a power. So, and last but not least, we've got to keep in mind that the bases have to be the same. Our power becomes a multiple. So this is a small example of all three of the properties of logs. You'll definitely need to understand the words expand and condense. You'll need to know that multiplication leads to addition, and addition leads back to multiplication. Division leads to subtraction. Subtraction leads back to division. And a power, or an exponent, leads to a multiple of the log. And of course that can lead back to the power. So if we come back to our notes here, if we come back to our notes here, we have example number 1, and you can see we have a lot of different things going on in this first example. So we need to break this down one part at a time. It's similar to order of operations in that you need to take one step at a time and not try to do it all at once. As you get better at each of these properties, you'll be able to start to break these things apart in multiple steps. But first I just want you to start off with some simple steps. And so we can see the first easiest thing to do is to take the division sign and make it a subtraction statement. So we break the log up into two separate logs through subtraction. Then our first log has some additional parts in it. 7x to the third not only has multiplication, but it has a power in it as well. I'm going to recommend that you save the power till last, since the power of 3 is only going with the x. So it's very important that you understand that this power of 3 only goes with the x. It does not go with the 7, and so you would not put it in front of the log base 2 with the 7. So it's very important that you split that up first. And then you have a completely expanded log. So you definitely want to be looking at the directions and understanding what you need to do with these problems. So what we'll go ahead and do right now is pause the video and try sample problem number 1. Be sure to expand this log fully and not to stop short. Okay, let's take a look at this example. First thing I'm going to do is I see that I have multiplication here, so I want to break this up first. Remember that we need to use the same log base for each part. So I've taken log base 5 and I've split it up into 2 logs, and that was 2 times x to the 6, so that's the same thing as 2 times x to the 6. The power of 6 only goes with the x, so we'll want to break those apart. Then we have a power here, power of 6, which can then become a multiple. So this gives me log base 5, 2 plus 6 times log base 5 of x. And if you feel more comfortable, you can always separate those with parentheses. And so that would be our final expanded version of the original log. Alright, well, let's reverse this process and let's see it going the opposite way. So you can see in example number 2, we're condensing the logs. So you can see here we've got a couple things going on. We've got an addition, we've got a subtraction, and we also have a multiple in front of that log. Notice that there is no base, and remember that if there is no base, so if we take log 6, the base is understood to be 10, and since it's understood to be 10, you do not have to write it whenever you're condensing this log. So as long as they all have the same understood base of 10. So we can start this in many different places. The place that we're going to want to start with initially is moving that multiple back to a power, and then at that point you can do the multiplication first and then the division, or you can go the opposite way. Going left to right is sometimes preferred whenever you're condensing, so starting whatever's on the left and then slowly picking up what's on the right. You'll have to get a feel for these problems and see how to put them together, which parts work easiest for you. So you can see that we took the addition of these two logs and we brought them together through multiplication. Then we took the subtraction and made division. And then last but not least, if you look at this, we have a lot of numerical values in there that can also be condensed. So 2 squared is 4, 4 times 6 is 24, and then 24 divided by 3 is 8, leaving us our final condensed log. Right there, log statement right of log base 10, 8. So be sure that you condense all the way down to the simplest log possible. So if we have multiple log statements, we want to get down to a singular log statement. So go ahead and pause the video at this point and try sample problem number 2. Okay, if I'm looking at sample problem number 2, the first thing I'm looking at is this multiple. I want to get this multiple back up as a power, so I'm going to make this log base 3 7 squared, and then we've got another multiple on that side, so I'm going to make that log base 3 x to the 5th. So I've taken care of both my multiples. Since I have the same log base, I can combine these together from subtraction to division. So I've got one log now, and I have 7 squared over x to the 5th. And of course I want to condense any numerical values possible, so I'm going to continue to do that, and that's log base 3 49 over x to the 5th, and we are now down to a single log statement, so that problem is condensed as far as possible. So that ends our lesson on log properties. It's very important that you learn these 3 properties very, very well. They are an ACT topic that is tested on the ACT when logarithms pop up, and then converting from logs to exponents and exponents to logs is also a property that you would need to know. In the next lesson, we are going to actually take the previous 2 units sections and put them together to help us solve log and exponent equations.